Hello everyone. Can everybody hear me? Okay, good. Um, Welcome to today's Introduction to Android App Development workshop. I am Samin. Short intro about me. I'm a grad student here at NC State. One of my research focus is studying the security of Android applications, and I have little experience in working as an Android app developer before joining here at NC State. It's my first experience in conducting a workshop, so a bit nervous but equally excited. So let's get started with today's workshop. Hope you guys enjoy it and benefit from it. Today's workshop is going to be an introductory workshop on Android app development. If you have no idea about Android app development or you have very little idea regarding some of its concepts, it's going to be a good starting place. We are going to take a look at the Android ecosystem, then how Android architecture is designed. Then we will look at what are the tools required if you want to develop an Android application. Then we will dive into some of the core fundamentals of Android app design. What are the basic components, how they interact with the system, how you write the code for those. And finally, if I have time, I will give a short demo on how to build and run your very basic app using Android Studio. Uh, if you guys are familiar with Java programming language, some programming concepts like object-oriented programming, inheritance, it would be helpful because these are some skills you would require to develop Android apps. Okay, some other people might be joining. They're on GitHub Workshop. That's good. So what exactly is Android? Yes, it's a mobile operating system. In fact, it is the most popular mobile operating system right now. Under the hood, it is built on top of Linux kernel, and Android is open source. That means the source code of the Android operating system or any app that is written for Android, that is publicly available, and you can modify it, customize it according to your needs, and you can distribute them. That's why we see many customized version of the Android operating systems. Those custom mods in XDA developers website. That's the beauty of open source. Around 72% of the mobile device people are using right now runs on Android. And there are more than 3 million Android apps available in Google Play Store. And guess what? Google Play is not the only app store you can download these apps from. There are also third-party app stores like Amazon App Store, GetJar, Opera, and some others you might not have even heard of. Is Android operating system just limited to just mobile phones? No, we have smart watches, tablets, Android TV, and even Android system can be installed in your car. So we have these cool ways of making our gadgets smart, and it's expanding day by day. The Android project was first initiated in 2003-2004, and the first commercial release was in September 2008. After that, it has been going through frequent incremental updates to improve the performance and security issues, as well as adjusting with user needs and demands. I used to like the fact that each version of Android would be named after a dessert, and it was in alphabetic order. The first one like this was Cupcake, then Donut. After a while, we had Kit Kat, Lollipop, Marshmallow, and it went on like this until we had Android Pie. Then suddenly, they changed the naming convention, and we got Android 10. The most recent version of Android is Android 11, which was released last September. Now, as they're introducing versions of Android, they're adding new features to the Android framework. For example, facial recognition that was introduced in Ice Cream Sandwich. Now, as you are going to write your own app, you need to specify a minimum API level for your app. That means what is the minimum Android version a user needs to have if he wants to install your app. So you would probably want to set a minimum version as low as possible because it would make your app accessible to most of the people. But there is a trade-off. the older versions would not have the API support for the new cool features. Therefore, you need to make a decision there that I'm going to support minimum API level X, and it will be available to Y% of the users. One of the major changes that was introduced in KitKat was changing the runtime environment. So they switched from Dalvik to Android runtime. Now, what exactly is this runtime environment? As you know, an Android app is almost like a Java program. Java is a platform independent language. That means if I write and compile a code in Java, I can run the exact compiled code on Windows or Linux or Mac. Unlike other languages like C, where you need to compile the program separately for different operating systems. So this is achieved by installing something called a runtime environment into your machine. And in Java, it's called the Java Virtual Machine. It does the architecture-specific translation of the compiled code. Therefore, you do not need to compile your code every now and then for running it in different systems. Android follows the same procedure. Here, instead of a Java virtual machine, we have the Dalvik virtual machine. So Dalvik would do the platform-specific translation every time you are running the app. It would therefore make the app take more time to start, and it would consume more battery. Since Android KitKat, they introduced this new runtime environment called Android Runtime, or ART. In Android Runtime, the platform-specific translation they happens when you are installing the app, and that happens only once, and therefore the app starts faster and it consumes less battery. But the downside is it takes additional storage. So if you want to know more about this Dalvik versus ART topic, I have provided a link below in my slide. Now let's take a look at how the Android architecture is designed. You know, there are a lot of hardwares and sensors in our Android devices, the camera, the microphone, Wi-Fi adapter, proximity sensors, and so on. And as an application developer, you would like to use these resources, but you do not want to deal with the low-level code associated with these hardwares. Therefore, we have this multi-layered abstraction. Android has a stack-based architecture. That means all these layers are stacked on top of each other. On the bottom of the stack, we have the Linux kernel. Over that, we have native libraries and Android runtime. On top of that, we have the application framework. And on the very top, we have the application layer. The application layer consists of system apps and other user-defined apps. So there are some apps that comes with the pre-installed phone, like the dialer app or the built-in camera app. So those are system apps. We can also install our own apps from App Store or from an APK file. Those are user-defined apps. So they consist the application layer. Below that, we have the Android application framework. So this layer consists of the classes that are required to build an Android application. For example, the activity manager, the package manager, the notification manager, and so on. So this is also known as the Android SDK. Remember, I said that when a newer API levels, newer features are added in Android, those new APIs are introduced in this layer, which is exposed to the app developers. Then we have the Android runtime. As we have seen, applications run in Android runtime. All the applications have its own instance of ART. Then we also have the native libraries, which are basically C and C++ libraries. This will contain all your high-end libraries like graphic libraries, OpenGL, SSL libraries, SQLite database. And finally, we have the Linux kernel, which handles the low-level memory management, multi-threading, access control to resources. So any request of accessing a particular hardware like camera or microphone would go to the Linux kernel, and it would decide whether to grant that access based on the permissions specified on the app. So the kernel has the ultimate governance. It enforces the security. Okay, now that we have known about the Android architecture, let's talk more about Android app development. As an Android app developer, you would face multiple challenges while developing an app. First, is supporting multiple devices. So there are a lot of devices with different screen sizes and resolutions. If you are designing the layout of a user interface, you have to take into account that how would it look into different devices with different screen size and resolutions. Then you need to support older devices. Like I said before, you have to decide between the minimum SDK and impacted users. Then you need to make sure your app is responsive and smooth. It does not crash now and then, and all the edge cases are covered. This would ensure a better user experience. Then one of the most critical challenges that is often overlooked, you need to make sure your app is secure. It is not using unnecessary permissions. It is not storing sensitive user data. It is not using HTTP URL for accessing critical websites, and many more. Finally, you need to understand the user demands. There are so many applications out there. There are so many app developers out there. So if you want to make your app stand out, you need to make it unique. An Android app is a sequence of interactive screens the user interacts with. The application logic is implemented using Java, or there is a new language called Kotlin. You can use that too. The user interface of the layouts are written in XML. It is a markup language similar to HTML. You would be using the Android SDK and other Android libraries for this development, and your app would be executed in an Android runtime environment. Now, what are the prerequisites? So first, you need to have a development machine running Windows or Linux or Mac. Then it needs to have JDK installed. So JDK is the library for Java. You need minimum JDK 1.7, and you can download that from Oracle's website. Then you would need a IDE like Eclipse or IntelliJ. But for Android, the most recommended one is Android Studio because it has so many functionalities suitable for Android app development. For example, it has its layout editor where you can drag and drop UI elements to design your user interface instead of writing XML code. Then you need to download the latest Android SDK. This can be downloaded using Android Studio. And finally, you would need a device running Android to test your app. It could be a physical device, or it could be a virtual device or an emulator. Android Studio has its own built-in Android emulator. Okay, now let's see how an Android project looks like. So if you open a new project in Android Studio, the file hierarchy would look like this. First, we have this manifest file. It is very important. It's like the summary of your app. So when you are installing the app, your app installer first reads this file and obtains necessary information. This file would typically have what kind of permissions your app needs to run, what are the components of your app, and so on. Then we have this Java folder, and inside that you would have your application code written in Java. Then we have this resource folder where resides all the layout files. I mean, all the user interfaces you are designing, all the string constant values, all the images or icons, or any media file you are using, everything would go to the resource folder. And lastly, we have the build scripts like Gradle scripts, which is required for building the project. Okay, now I'm going to introduce you guys to some classes defined in the Android SDK. These are called Android app components. These are basically Java class with specific names, and each of them has a specific purpose. Application components are the essential building blocks of an Android application. Each component is an entry point through which the system or a user can enter your app. Some components depends on others. So there are four basic components: activity, service, content provider, and broadcast receiver. First, we have the activity class. An activity is a component which corresponds to a user interface. That means each different screen that appears in an app is called an activity or an instance of an activity class. Next, we have services. These are the classes that corresponds to a background task. So if you want to perform anything on the background, you need to write a service class because they don't have a user interface. Then we have broadcast receivers. There are many system events happening in an Android application's life cycle, and the applications are notified about those events through broadcast receiver class. And then we have content provider. If you want to provide some data or content to your app, this is a structured way of doing so. The class you need to work with is content provider. They're the provider of data. So other than these four components, there are some additional components which will be used in the construction of the above mentioned entities and their logic. So to summarize, there are four kind of classes in Android SDK with very different purposes. These are the Android app components. Okay, so now let's take a deeper dive into some of these components. An activity represents a single screen with a user interface. In short, activity performs actions on the screen. For example, an email application might have one activity that shows a list of new emails, another activity to compose an email, and another activity for reading emails. So as you are navigating through the user interfaces, you are basically calling different activity classes. If an application has more than one activity, then one of them should be marked as the launcher or main activity. That is, when the application is launched, that activity is presented. Typically, an activity fills the entire screen, but it can be embedded in other activities as or appear as a floating window. For example, the chat head of the Android Messenger app, those are floating activities. Since the activity is a Java class, and we said that we only implement logic in Java, therefore, to have a user interface, each activity needs to be associated with a layout file. The layout is usually defined in one or more XML files. When the activity is created, the layout file is associated with that activity and the user interface is rendered. Now, the activity has its own life cycle. This is because in Android, a screen might be running on the foreground and then some system event happens and it might send that screen to the background and bring some other screen to the foreground. So the Android system needs to model that in an activity. Therefore, the activity has a life cycle with several states, which is handled by some callback methods of that activity. Here we can see the life cycle of an activity. An activity might be in several states like created or started, resumed, and so on, which is triggered by several callback methods like on start, on create, on resume. Let me try to give an example here. Suppose you have an email app. The email app has many activities, but let's say we are considering the life cycle of a login activity, the activity that is used to log into the email account. So as you, when the application is launched, you click the email icon on the home screen. Now, before you click the email icon, that login activity does not exist. When you click the email icon, the onCreate function of the login activity is called, and that activity goes to created state. And at this point, the login page is not still visible. Then the onStart method is called, and the activity is brought to started state, and after calling the onResume method, it goes to resume state, and at this point the login activity is running on the foreground and you can see it on your screen. Suppose now you provide your credentials, your email address and your password, and you press the login button to go to the next page. Then this login activity is sent to the background. It is in stop state because it calls the on pause and on stop methods sequentially, and the next activity is brought to the foreground. Now, if you press the back button of your Android device, this login activity will be back into resume state, calling on start and on resume. So at any point, if you kill the app, the activity would go to destroyed state by calling on destroy. So this is how the states of the activity is managed in Android. So we see that these various callback methods gives us the flexibility to handle what happens when an activity, when it is shown on the foreground or sent to the background. For example, when the onCreate function is called, we would like to associate our layout file with the activity so that it is rendered. Let's look at a sample code where we can design an activity of our app. First, we need to extend the activity class. Then we need to override the onCreate method. We would initialize any variables that our class uses here. It's like a constructor in Java class. Here we can see that we are calling the setContentView method and passing a XML file. What this method does is when the activity is created and is on a resume state, it would show us the layout specified in activity_main on the screen. Now we have to write our layout file. You don't have to worry too much about writing an XML file because Android Studio will generate this XML file automatically. What we did here is we declared a layout and we declared a text view inside that layout, which has a text set to hello world. So if we run this application, we will see a screen like this. Next, let's talk about intent. It is not a basic component like activity, but we need to understand what intent is for better understanding the other components. And intent is a class which is used for passing messages and signals between activities. For example, you want to trigger a new activity. You do that using intent. Or you want to pass some data between activity A and activity B. You need to pass that using an intent. Now, there are two kinds of intent, explicit intent and implicit intent. If we know the destination activity, specifically its class name, then we can create an intent object using that explicit class name, and it would be called an explicit intent. Use case of this is, suppose I'm triggering another activity of my app. In that case, I know the class name, so I trigger that using explicit intent. Now, an implicit intent is where I do not know the destination class name. For example, I need to navigate to an activity which would show a coordinate on the map, or make a phone call, or which would open something on the web browser. Now, my app might not have that built-in phone dialer or map navigation or built-in browser, but I might use some existing app on my device to perform that action. I can do that using implicit intent. In this case, rather than specifying a class name, I specify what kind of action I want to perform. So that is an implicit intent. Okay, so let's look at some code. I have this activity, activity A, which has a button. This button has a on-click event associated with it. That means if I click the button, whatever code that is written on the on-click method would be executed. I want to launch activity B of my app when I click this button. I can do that by using explicit intent. because activity B belongs to my app and I know the class name. So I create an intent object. I explicitly pass the class name here, which is activity B, and then I call the start activity method. This will bring activity B onto the foreground of my screen. Now note that you can pass additional parameters from one activity to another activity. In that case, we can use put extra and pass a key value paired. Now suppose I want to do some task that is beyond the functionality of my app. I have this very simple app, but I want to browse a URL provided in my app by a user. I can do that by using implicit intent. Just like the previous example, I have this on-click method associated to my button. Now, I do not know the class name of the activity of a browser app, say Google Chrome. I don't know what is the class name of Google Chrome's browser app. So therefore, I instantiate the activity with the argument intent.action_view. And I pass the navigating URL. Now, the way this works is the Google Chrome browser app has registered for events like action_view. And when such an action is triggered, the Android system will check which activities have registered for that specific event. If it finds such an activity, it launches that activity to handle that event. In case there are multiple activities registered for such an event, it shows the activity chooser so that the user can choose which app to handle that request. Okay, now let's talk about services. A service is a component that runs in the background to perform long-running operations. For example, a service might play music in the background while the user is in a different application, or it might fetch data over the network without blocking user interaction with the activity. Services are triggered by other components. There are usually two types of services, bounded and unbounded. If you want to bind a service with a component so that as long as that component is alive, the service will remain alive, that is a bounded service. Otherwise, it's an unbounded service. An unbounded service is triggered by calling the start service method and stop using onDestroy method. It does not matter whether the component that initiated the service is alive or not. Whereas a bounded service is triggered by calling the bind service method, and a bounded service can be binded to multiple clients. And it keeps on running as long all the clients have not unbinded it. So to stop a bounded service, all of the clients need to unbind it first. Let's look at an example of service. So in this case, we are considering unbounded service. So we have this activity where there are two buttons, a start button and a stop button. By clicking start, we want to start this service called new service. And by clicking stop, we want to stop this service. As we have discussed, to start an unbounded service, we need to create a service and call the start service method. So inside the on-click listener of the start button, I have instantiated an intent with this new service class, and I have called the start service method. Now let's take a look at the code for this new service class. So since this is a service, it needs to extend the service class. Because we define it as an unbounded service, we override the onStart command and onDestroy methods instead of the onBind method. In this case, whatever service we need to run, we write that code inside the onStart command. In this case, we are trying to instantiate a media player object which keeps playing the default ringtone on loop. If we want to stop the service, we press the stop button, which calls the stop service method in the activity, which triggers the on destroy method. So whatever we want to do when the service is stopped, we put that code in this on destroy method. In this case, we are stopping the media player. So this is how the service works, and it runs on the background. You can see that it does not have a user interface. It is triggered by the activity. Okay, now let's talk about broadcast receivers. Broadcast receivers simply respond to broadcast messages from other application or from the system. There are many system events that you want your app to respond to. For that, you need to register a broadcast receiver. For example, you want a specific component to react if the battery level is low, or if the Wi-Fi status is changed, or if a headphone jack is disconnected. So this is handled by broadcast receiver. You can also register for custom events. For example, your application can initiate broadcast to let other applications know that some data has been downloaded to the device and it is available for them to use. So this is broadcast receiver who will intercept the communication and will initiate appropriate action. While implementing a broadcast receiver or triggering a broadcast event, you need to keep in mind its security implications. The broadcast message can be intercepted by any app that has registered for that broadcast event. In those cases, you might want to add a permission for enforcing security. To implement a broadcast receiver, we first need to extend the broadcast receiver class and then override the onReceive method. This onReceive method gets executed when your app receives that broadcast notification. Then we need to register for this broadcast event. We can do it in two ways. We can do that statically by specifying that in the Android manifest file, or we can do that dynamically by calling the register receiver method in a component. Just keep in mind that if you are statically registering for a broadcast using the manifest file, that event is registered indefinitely. That means if your application is not launched, if it's not running, your components would react to that broadcast event. But dynamically registering for a broadcast event would limit the invocation of the broadcast receiver. It's gonna react only when the app is running on background or foreground. And it is possible to trigger a custom broadcast event using the send broadcast method. And all the system broadcast events, they're triggered automatically. Here, let's look at an example code. We are creating a broadcast receiver, and therefore we have extended the broadcast receiver class. And we have overridden the onReceive method. Upon receiving a broadcasted event, this class shows a toast message saying broadcast detected. Now, let's register for this event. We first statically register this event using the manifest file. We here add the action android.intent.action battery underscore low on its intent filter. That means whenever the battery goes down below a certain percentage, whether the app is running or in the background or not even running, we will see that broadcast received message. Now let's register the receiver dynamically inside a component. For this, we first need to create the broadcast receiver object, which we have an instance of the myReceiver class, and we need to create an intent filter for this specific action. In this case, it's android.intent.action battery underscore low. We then call the register receiver method in the onCreate function of my activity to register to register our broadcast receiver for this specific intent filter action that we have defined. Note that we need to unregister the receiver by calling the unregister receiver method in onDestroy method of the activity lifecycle. Here in this case, the broadcast receiver will listen even if the activity is in the background. But say you want to register your receiver which only reacts when your activity is on the foreground. In that case, we need to register the receiver on onStart method, and we need to unregister the receiver on onStop method, because when your activity is going to a background, it's gonna call the onStop method. So before going to the background, it's going to unregister your receiver. And similarly, when it is coming to the foreground, it's going to call the onStart method first. So it's going to register the receiver. So calling this register and unregister functions on different callback methods of the activity lifecycle, we can actually manipulate when the broadcast receiver action is going to be triggered. Okay, then we have content provider. A content provider is a component that supplies data from one application to the other one. Such requests are handled by the methods of the content resolver class. The data may be stored in the file system or database or somewhere else entirely. A content provider is implemented as a subclass of the content provider class, and it must implement a standard set of APIs that enable other applications to perform transactions. When you have defined a content provider, you can access the content it provides using the content scheme. Say, for example, my app has a database with a table called people, and I want to access the element at row 10. I can access the content using the URL mentioned here. Now, I want some other application to access the same content. Without providing that application my database table scheme or what are the table names, I can provide this content provider URL for that application to access the content of my database. The last component we are going to talk about is the app manifest. So this is a file which describes the contents of your application. If you look at the sample manifest file here, you can see that it includes the app package name. It includes what kind of permission the app requires, read phone state in this case. Then a very, very important issue is every component you define in your app, it needs to be present in the manifest file. By component, I mean the 4 basic ones. Otherwise, while compiling your project, you will get an error that component not found. You need to specify intent filters in the manifest file. Remember the browser app that could be triggered by an activity of your class. If you want any activity of your app to be triggered by an external app, you need to specify an intent filter for that. And that is specified in the manifest file. Then there are some auxiliary informations like your app label and icon, which is shown on the home screen, what hardware and software features your app needs. All these stuffs are also provided in Android Manifest. Okay, now I plan to show a short demonstration on how you can run Android Studio and how you can launch your first Android Studio, your first app using Android Studio. So this is Android Studio, the developer IDE for developing an Android application. Here you can create new project, you can open existing project, but let's first see the SDK manager menu. So you need to download the Android SDK before you start writing your first Android application code. So if you click the SDK manager, it will bring you to this console where you can easily download the latest API levels for Android. You want the latest one downloaded so you can have all the new features. Then you can go to this SDK tool tab where you can download some additional tools. For example, you can download the Android emulator. You can download some services. For example, if you want Google Maps support or Google Play support, you need to download Google Play services. So this is an easy way to download all those stuffs. Okay, now you want to create a new project. You get introduced to this template window. So some of the templates have some advanced UI widgets integrated to it. For example, this navigation drawer activity, it already adds that navigation menu, which is brought when you are swiping from left. But right now, I'm gonna stick to an empty activity. So I'm gonna press next. Then you will give your application a name, and then you will give a package name. Now, it is important here that you make this package name unique, because when you are uploading your app on Google Play Store, if this package name has a duplicate, you will not be able to upload that. So you need to create a unique package name there. Then as we have discussed, you need to specify a minimum SDK, and you have to think about the trade-off between minimum SDK and impacted users. I will click finish here. So my project is loaded. It's going to take some time to do the initial configuration. So this is like IntelliJ or Eclipse. On the left side, you have the project navigation window, and on the right side, you have your coding pane. Let's see. So I can see that my project has been built. Now to run my project, I first need to set Android emulator first. So I can go to Tool and I can go to AVD Manager. It brings us this menu. So from here, you can create a virtual device in case you do not have an Android device. You press the Create Virtual Device button, and it gives you all the options. So I can emulate a Pixel XL phone. So I click one of them and press Next. It then shows you which Android OS version you need to download on your emulator. So you would probably want to download the latest one, of course, and it also lets you specify which processor the emulator would be emulating. So there are Intel processors like x86, and there are other processors like ARM. But if you are running a machine that has an Intel processor, you might consider using an image that emulates the x86 processor, because it's going to be faster than the other ones. So I'm not gonna create a virtual device right now because I have already one that is instantiated. So I'm gonna launch this emulator using this launch button, and you need to keep in mind that so you need to keep in mind that you do not want to load this emulator every now and then, because it's going to take some time while it is being loaded. So as you are developing your app, you should not probably close it every now and then. Okay, now let's look at the layout editor. So if you click a XML file or a layout file which is available from the layout folder, you can see this layout editor window. Now from here, you can easily drag and drop the UI elements to the screen and make it available. So on the left side, we have all these cool widgets that we can use. So for example, I want to put a button on the screen. I simply drag and drop it here. It's that simple, and it appears here. As you are using a UI widget, on the right side, you can see the attributes you can specify for this widget. For example, I can easily change the button name here. Please keep in mind that you need to specify some constraint of this widget, like where it is positioned. Because if you do not specify any constraint, it's gonna appear arbitrarily depending on which device it is loaded on. So you need to specify some of the constraints here. Now, as you are doing this drag and drop, the equivalent XML code is being generated here, which you can access from the code tab. So here you can see the button that I have just added. It has been added in the XML file automatically. Now, if I change it, the values here, say dummy button, I will see that this value is updated on the layout editor as well. Okay, now let's look at the code. So I'm not going to edit stuffs here because we have talked about how to extend the activity class and call other activities. So I'm simply going to run the app and see how it looks on my emulator. So it's going to take some time before loading the application. Let's run it again. Okay, so my app has been loaded, and I can see the button that I have added here is here, and so is the Hello World text. So this is how simple you run your first Hello World application using Android Studio. Okay. So that's all I had prepared for today's presentation. I want to wrap up by thanking you guys for attending this workshop. I hope that you had something to take away from the workshop. The dummy code that I have used in my examples, that code is available on Hacker's Guide if you want that. And if you want further help with some explanation, you can reach out to me using my email, or I'm also available on Diamond Hacks Discord. So with that, I want to end this workshop. Thank you for attending.